we are going to learn about chromatography techniques. We already seen some of the types in the previous videos. So in here we are going to learn about some of the types here. So in this video we are going to learn about in the column chromatography, HPLC, and the ion exchange chromatography. So basically chromatography, in the sense it is the separation of mixture of the compounds based on the separation techniques. So in the column chromatography, in the sense it is the technique, it is one of the physical technique. In this technique, the stationary bed which is happened within the tube. The absorbance of it will be make up or packed within the glass tubes. So in the absorptions, in the sense it may be used as here the silica gel or alumina or charcoal powder or calcium hydro is are used here. So in here, so this is the column 1. So the column tubes, they are made up of the glass tubes. Here they are, the absorptions are packed within here. The samples, the mixture of the solvents are loaded into the columns. The individual compounds are get differently absorbed to the absorbents. So the elutions is carried out the different buffer systems which is mobile through the phases. So the individual of the components, they are come out the columns. It may be different rates which may be the collected, separated, and it will be finally identified. So these are the common principle and the procedure for the column chromatography. The next one is the HPLC. The HPLC, in the sense it is the hyper performance of liquid chromatography. So liquid chromatography, in the sense here the mobile phase is act as a solvent, but in here instead of the solvent the higher pressures are used here. So HPLC, it is a basically high improved form of the liquid chromatography. As well as I already said, it is instead of using the solvent or in the mobile phase being allowed to drip through the column under the gravity, it is forced through under high pressure. So the yield of the high performance and the high speed as compared with traditional column chromatography. Here the parameters are used in the HPLC is referred to the nature, the type, and the size of the packaging materials. So that's only it will be defined. And the increase of the flow rates are obtained by the applying pressure different across the column. So based on the pressure whatever we given, it only to given our analysis materials. So these are the common basic setup for the HPLC one. What is the advantages of the HPLC, in the sense in here the development of the stationary supports with a special or very small particle size and large surface areas. The improvement of the elution rates are in here, they are applying by the high pressure to the solvent flows. What are the applications of the HPLs? In the sense they are applicable in the most of the fields. Here we are going to see in the some of the areas alone. So in the pharmaceutical, in the sense it will be determine the shelf life of the pharmaceutical products, and it may be identify the different drug products and the pharmaceutical quality controls. It may be done by the HPLC. In forensic, in the sense it can be used for the identification of anabolic steroids for in the serum or urine or sweat and the hair samples. It may be also used as the determination of the textile dyes, the stimultaneous quantification of the psychotherapeutic drugs in the human plasma. In the field of the clinical, so it is mostly used in the analysis of the antibiotics and the detection of the endogenous neuropeptides in the human, in the brain, in humans, the brain extracellular fluids. In the food and flavor area, it is ensured the soft drink consistency and their quality, and it is also used to analyze the sugars analysis in the fruit juices, and it is also used as the analysis of the alcohols too. The next one, ion exchange chromatography. So from the name itself we know that, so here the ions are exchanges through that. So this is a basic process in the ion exchange chromatography. So the ion exchange chromatography is a process by which a mixture of the similar charged ions can be separated by using an ion exchange resin, so which exchanges ions according to their relative affinities. Here the main principle is absorption. So the based on the exchange of the ion between the charged stationary surface and the ions of the opposite charge in the mobile phases. So here the stationary phases act as a solid. It is containing the ion exchange resins. And in the mobile phase, in the sense here the solvents or the liquids are mostly used as liquid form is used in the mobile phases. So depending on the conditions of the solutes are either the cation or anion. So these are known as ion exchangers. So the stationary phases, so what we are going to separate in the sense, it will be categorized in the two types. So they are anionic stationary phase and another one cationic one. So if you are want to analyze, if you want to separate the cation ion, in the sense you are going with the anionic stationary phase. If you want the anion, in the sense you will go with the cationic stationary phase. So these are the common stationary phases examples. So based on it, we will be analyzes it. And the mobile phases, here we are not going to use at the organic solvents, not here used it. So only it is used as in the different strengths of the acids, alkalides and the buffers are mostly used as the eliciting solvents. For an example, 0.1 HCl or 0.1 sodium hydroxide are phosphate buffers. So likewise they are used as a mobile phases. In the column preparations, so here the column preparations are the columns are mostly made up of the glass or stainless steels are made up of. So here the packing in the cells, the resins are mixed with the mobile phases and it is packed in the column uniformly. The samples are to be separated is dissolved in the mobile phases and introduced at all once in the column into their column. The elucidations are based on the if you are going to use the same solvents or same procedures are going to carry on throughout the procedure, in the sense it will be known as the isochromatic. Or if you are want to changes in the throughout the procedures, if you want the changes in the concentrations or in the acid or base or the pH, likewise in the sense, so it will be known as the gradient elutions. The analysis are done by so many methods are here. The spectrophotometric method or polarographic method, the conductometry method or amperometric method and potentiometric method. So those are the methods are used as detector for the final analysis. So these are the common one. So based on which we are going to get our result. So the opposite charges will be act as the absorbent and finally we will get the one and finally it will be analyzed. Then applications. So these are mostly used as a softening of the hot waters, demineralization of the water and analyze basic compositions of nucleic acids, the concentration in the metal ions in the samples, measures the additives in the food and the drug samples, and finally it is also used as to separate the protein mixtures. So up to this I conclude my video. Thank you.